and welcome to today's webinar. I'd like to introduce today's presenter, Dimitro, a famous YouTuber, Angular developer, instructor, and a tech enthusiast. He will guide us through the steps in optimizing and speeding up your web applications. For those of you who've just joined us, we welcome you and thank you for joining our webinar. And just a friendly reminder that we will conduct a question and answer survey session after the webinar. Make, make sure to get your questions ready so our presenter can answer them at the end. We'd love to hear from you. And without further ado, Dimitro, the floor is yours.
Hello. Okay. All right. Can anybody confirm that you can see my screen?
Yes, we can see your screen now.
Okay, awesome. Yeah. Hello, everyone. My name is Dmitro Bozhensky. I'm a Google developer expert for Angular, and I'm also the author of YouTube channel Decoded Frontend, as it was already mentioned. There I focus on mostly advanced Angular topics, and my videos mostly about that. So if you work with this framework, with Angular framework, then please can go subscribe to the channel. I'm pretty sure that you will find a lot of interesting stuff there. But today I would like to talk with you about a topic that is not strictly related to Angular, and it is more, generic one that fits any front-end frameworks like React, Vue.js, or even vanilla JavaScript project. And it will be some set of tips that you can use already now. They usually don't need any additional setups or anything else, or even if they require some setup, it is quite simple ones. But those tips can give you some performance boost for your existing and future web applications. There will be tips for, so to say, different levels, like for juniors, for more experienced developers. I will try to cover all of them. And all right, then let's get started. And this is main topics that we will cover. There will be 4 sections. We will talk about graphic optimization, like images and so on. Network optimization, we will talk how to improve page loading and how to improve JavaScript runtime performance. Also in the end, there will be additional bonus section like team performance, so stay with us if you want to hear that. And as I said, each of this section will have some set of small tips and tricks you could apply for your project as well. And let's get started with the very first topic called graphic optimization. Well, unoptimized graphics, it is one of the most, so to say, popular causes of bad performance and UX. So that's why you have to pay attention to it in the first place. And it is better to care about that already from the very beginning, obviously, when you start the project. And let's have a look what we could make better. So first of all, and the easiest is to use proper image pixel resolution for raster images like PNG, JPEG, and others. It seems very obvious, especially for experienced developers, but I see this problem quite often, especially for beginners who just started with web development, and they do that quite often. So, like, what I mean is when you get some template from designer, yeah, and according to this template, you got some image banner that has size like 500 pixels width and 300 pixels height. Don't use for that the image which has 5,000 pixel width and 3,000 pixel height, because like the second image will be 10 times bigger, and it will take much more time to load this image without any actual win on the quality side. Yeah, so you most probably will see no difference. Yeah, there are some cases when we would need to use images bigger than the actual size, but this is the edge case that we'll cover a little bit later, and there are like better techniques how to perform that things. The next step is utilizing tools to minimize the image size. And here I'm talking not about the resolution of the image, but the size like in megabytes. Yeah. The thing is that besides the visual part that we actually see when we load the image, we besides this information, besides this visual part, the image has also such a thing as meta information, or also known as a metadata. And metadata, it can be usually it is some information about I don't know who is an author of the image, when it was created, edited, etc., etc. So this information takes some space, but most probably we don't need that information when we display it on our website. So this data can be removed without losing the image quality, in such a way we can reduce the size of the image. And the metadata is just an example. Yeah, there are a lot of things that can be removed without image quality reduction, or even if it happens, if we reduce a little bit the quality, you can hardly see the difference between them, especially if you don't compare images next to each other. So but you can reduce size like drastically. There are also tools and libraries that help you do that. Like you can do it, of course, manually, but yeah, we are developers, so we want to automate things. So you can use tools for that. And for instance, if you use JavaScript bundlers like Webpack, there are already dedicated plugins like Image Minimizer Webpack plugin, which allow you to optimize your images and automate it. If you use some another bundler like I know Rollup, or some task runners like Gulp, etc., then you can Google for some similar plugins for them. It's pretty like important and widely used tasks, so there are definitely plugins for other bundlers and tools that will help you optimize your images. The next cool thing, which doesn't require any additional configuration, is that you can load images lazily by using a loading attribute for the image tag. This technique allows you to delay the loading of images that are outside the viewport view. But do not spam with that everywhere, especially for the images that are supposed to appear immediately within the viewport. It is recommended to do this lazy loading, or loading lazy attribute for images that are positioned below the fold. So if you start to spam with this and put this property also on the images that appear immediately within the viewport, you might get even the opposite result from what you expect. I mean that you will not improve the performance, but it can degrade in some cases. And by the way, the iframe tag, I'm pretty sure you all know this. It's quite popular iframe tag. It also has a loading attribute. I didn't include this on the slide, but yeah, just for you to know that it supports also lazy loading like the image, but it has worse browser support. If I remember right, yeah, there's Safari, which doesn't really support it, or if it supports, it's in technology preview mode, and Firefox, as far as I know, doesn't support it at all. So that's why I didn't include this, but for you, just for you to know that it exists, so you can Google for it. Regarding the lazy loading attribute for the image, the browser support is quite good. All modern browsers support this property and works well, except Internet Explorer. I believe Internet Explorer doesn't support it, but who cares nowadays about Internet Explorer, right? But yeah, let's move forward. And what else you could do to improve graphics on your website? Well, consider using SVG images where it is possible. What are SVG images? SVG is an acronym for the scalable vector graphic. And unlike raster graphics that uses pixels in order to display the image, SVGs do not rely on these unique pixels to make the image. Instead, they use a vector data. And one of the coolest features of vector graphics is that it doesn't lose the image quality when you scale the image. You can take same SVG image and make it, I don't know, 100 pixel width and 100 pixel height, and then scale it up to, I don't know, 10,000 pixels width and height, and the quality of the icon will not change. The image will remain sharp and nice looking. Doesn't matter how much you will scale it, which is not the case with the raster graphic like PNG, like JPEG, and so on. And SVG graphics also behaves perfectly on different screens with different PPIs, like Retina screens whatsoever. And again, the JPEG, PNG images, they can be blurred on Retina screens if you don't adjust them additionally. We will talk about it a bit later. And what else about SVG images? Yeah, they have quite a small size, which has definitely also positive impact on the speed of the page loading. However, despite all those benefits, you cannot use SVG graphics everywhere, unfortunately. For example, because of its vector nature, SVG works not so well for images, not well for images with lots of small details and textures like photos. Also, very detailed SVG images then have they can have a bigger size compared to PNG, and you should look at what you would like to achieve. For instance, sometimes it's better to use PNG because it has less size rather than SVG. And if you see that you don't need to scale this image or do anything else where SVG could be beneficial choice, then it would be better probably to go with PNG. Yeah, so this is something you have to decide always. But where SVG works the best is icons, stuff like icons and logos, because those elements, they very often need to be scaled and they need to be lightweight. In addition to that, SVG graphics can be easily animated or repainted with another color. It doesn't directly impact the performance, but yeah, I just wanted to mention how powerful is this format. Yeah. By the way, however, if you would need to, if you have two icons, by the way, and you need it in two different colors, then you can just use CSS to change the color for SVG icon and load only one SVG icon. And if you would use PNG, you would need to load two icons. So basically, it also kind of optimization, yeah? So you would need to load only one SVG icon and reuse it everywhere with different colors, and you don't need to load another one, which is actually cool. Yeah, and this is what about SVG graphics. But let's move forward and yeah, have a look at source set attribute. How can it improve our performance? Using the source set attribute, you can define which exact image version to load depending on the screen size and screen PPI. For example, if I have a banner on the main page that has a size, I don't know, 1600 pixels width and 800 pixel height, it would make sense to load it only if the user browses the web page from a laptop or like from some big screen. But if user uses the mobile device, it makes no sense to me to show this huge banner, right? It would make more sense to load a smaller version of the image that might be also optimized for small screen. I mean, that sometimes we have on the images some important piece of information or graphics that needs to be always visible. And when you scale, when to try to scale one image for different sizes, sometimes these details might be cut, but it will allow you to load another variant of the image, of the same image, but it will be adjusted just for the small screen. And in such a way, you can also reduce the page loading time by reducing the image size for the small screens. And also you can improve the user experience. So two benefits from it. And also this attribute allows me to configure which version can be loaded for which screen. For instance, I mean, I can provide a set of variants. So if I have the screen which is up to 300 pixels, then there will be loaded the smallest possible version of the image. For the screen between 300 pixels and 600 pixels, there will be used the medium version, and so on and so on and so forth. Yeah, so it can be also it can work also with PPI. You can define which version of the image should be loaded for the depending on the screen PPI. If it's a Retina screen, like on MacBooks or whatever, then you would probably need to load 2 times bigger image, because Retina screen, they require that images will be bigger than the actual size maybe 2 times bigger, because otherwise it will be it will look very blurred. And yeah, if you want to have it sharp, you have to load bigger images. Okay, yeah, this is, I think it's everything I wanted to mention about the source set. And yeah, let's move forward. And yeah, it's partly related to the source set. Like, there are different libraries, and one of them called Filestack Adaptive. Those libraries can help you with just few lines of code, can help you to generate an image with the source set that contains a list of images that are appropriate for different screen sizes, which is cool and can help you save some time and efforts generating this source set for your applications. And now let's talk about network optimization. It is also very important because a very important part, because over the network we deliver all our scripts, images, and other assets. Properly configured networks can drastically improve this process, and yeah, let's have a look at what kind of techniques are existing that could help us with the network optimization. So, and the first and the most obvious technique is just reducing the number of HTTP calls, if it is possible. Check maybe you have some irrelevant assets on the page, or the good idea could be to combine all your CSS and JavaScript files into one single bundle. And yeah, when you design your API, your backend API, can try to design it in such a way to do as less as possible round trips for your HTTP calls to get data. Or you can also consider using something like GraphQL, for instance. This is a query language that can help you to fetch data in one single request, and in theory it can help improve the performance. But yeah, I know that if someone worked with GraphQL, he can say that, or she can say that it's quite of questionable when we're talking about the GraphQL and performance. But yeah, it is one of the options you could consider or get some inspiration there, because like GraphQL, very different in terms of performance. It can be like disaster, and if you properly design your API and your backend, GraphQL can be very, very useful and very performant, actually. So yeah, but yeah, let's move forward. And yeah, you can benefit from enabling the HTTP 2.0 protocol, which is more efficient compared to HTTP 1.2. HTTP protocol 2.0 is binary instead of textual, unlike the HTTP 1, which makes data transferring and data parsing more efficient and fast. And besides that, HTTP 2 is fully multiplexed, it allows multiple files and requests to be transferred at the same time, which is not possible with HTTP 1, which only accepts the single request or connection at a time. And basically, yeah, it solves the problem I mentioned above. So if you enable HTTP 2, then, for instance, bundling your CSS and scripts in one file is not really necessary, because HTTP 2 like doesn't care about that. It can in parallel loads your resources. It has no restrictions with that regarding that. So yeah, HTTP 2, this is good option to go. You can consider it, and it is usually very easy to configure. HTTP 2.0, very often you don't even need to touch the web server config, and you can do it actually manually in the hosting console or whatever you run your website. But if you need to touch the web server config, then you just need to add the HTTP 2 string to the listen property inside the config of your Nginx server. For Apache, it is also not so hard. I'm pretty sure I didn't work with Apache for a long time, so sorry about that. But if you need, I'm pretty sure you can easily find it in Google how to do that. Yeah, and while we are in the server config, we can also enable JZip compression to use JZip to compress files on the fly. So the idea is that files you transfer over the network, they are compressed before the transfer, and then they are being decompressed by the browser that support it and retrieve the data without the loss. But the benefit definitely of the smaller amount of data to transfer between web server and the browser, yeah, because we JZip this data before the transferring. And yeah, likewise with HTTP 2.0, it is very easy to configure. It can be done either on your hosting console again, or it's just one string in the Nginx config, just JZip on, and that's it. Yeah, just a few characters, and then you can get a huge gain in terms of performance. But usually it is enabled by default JZip, but you can always check and make sure that it is enabled. And of course, yeah, last but not least, don't forget about caching. Caching is your friend in most of the cases, yeah. It is very important. You can cache some static data like heavy images, scripts, and then browser doesn't need to load that file every time the page is loaded again. But instead, the browser will take it from the cache. Just be careful be careful with what you are caching. If it's something static, it is a great candidate to be cached. If it's something dynamic, like chat messages, then of course it might cause problems for you. Or it, from my practice, I remember cases when web browser cached the index.html page of single page application, and that's why the new changes they were not propagated to the application because it was cached, and then yeah, your updates are not arrived until the cache is expired, and the index.html file will be loaded, from the very beginning. Yeah, and you can control caching by sending appropriate caching headers and set different parameters. But this is the caching is a big topic. We need 10 webinars to cover at least something regarding caching. But you can always check on your own, and depending on your applications, you can choose some appropriate approaches that works for you. But we move forward, and yeah, it is here we'll talk about CDNs, and CDNs, it's plays very big role in the network optimization. And CDN, it's content delivery network that is represented as a geographically distributed group of servers that work together to provide faster delivery of the internet content. And because it really matters how far physically you are located from the server. The file will be resolved and loaded faster when the server is located somewhere in my backyard, yeah, rather than somewhere in California. And this is the problem that CDN solves. It delivers files from the closest possible server, and it eventually increases the speed, how fast is being delivered assets to your basically browser. Yeah. So there are a lot of third-party providers that deliver different scripts over CDNs, but some services have built-in ones. For instance, again, the Filestack service that helps you to upload and process files for your web applications. They can deliver this library over the CDN and additionally gives you some control over the caching, as you can see. So it is very good optimized for in terms of CDNs and caching. So now let's talk about page loading. Yeah. This is also a very important parameter that play a big role in user experience, and also it impacts the ranking of your website in the search results. So if it's so important, let's have a look what we can do with that, how we could improve. And yeah, again, let's get started from the easiest and the most obvious option. It's reducing the number of scripts. Sounds like very obvious, but in practice, we have a lot of, if we have a look at especially big projects, where you can always find there are some scripts that are being loaded. They're existing, but they're not being used, and no one deletes them because the guy who added this script doesn't work in the company anymore. It stays there, and like no one can dare to remove that. And I think it's a familiar story. Like for me, it happened a couple of times, and I would recommend you revisiting such things time after time, because such scripts and code tends to be collected more and more, and at some point of time you have to do this revisiting and clean up. So try to keep your scripts and libraries under control. What are you using and what you are not using, remove it. But this is the very easy and not always the easiest, but very obvious option. Then try to write reshakable code. Well, tools like Webpack and Rollup and maybe some other they have a cool feature called tree shaking. Tree shaking is dead code elimination. So basically, it analyzes your code and sees like, okay, you imported some function, but you didn't call this function. And if you didn't call this function anywhere else in your application, then it makes no sense to include this function in the final bundle, right? And in such a way, the Webpack, it will remove it, tree shake it. It will not include this function in the final bundle, and the final bundle will be more lightweight, and that's why it will load faster, and we get eventually the speed page loading boost. regarding the recommendation how to write reshakable JavaScript code, well, it is hard to give you an exact guide on it because bundlers like Webpack, they become smarter and smarter with every release and detect that code that can be reshaken more efficient. But there are some main rules, yeah, that you have to follow. And the first one is rely on static ECMAScript imports. Like do not try to avoid common JS model imports using the require keyword. It is, I would not say that it is not reshakable completely, but it Webpack can detect, but it works not good, really not good. For Webpack, it is hard to detect what needs to be tree shaken if you use a require keyword. And when you use static imports like import some function from some file, this new ECMAScript 5 imports, then Webpack can perfectly understand and remove the code that can be safely removed. Also try to do as less as possible side effects. Side effects, it's when you have a function and this function changes some, I don't know, global state, for instance, or some global variable, or the variable that just out of the scope of this function. This is side effect, and you should like try to avoid it as much as possible because this code also might be very hard for Webpack to tree shake it. Sometimes it can recognize, sometimes not. Of course, you cannot avoid side effects completely, but yeah, try to keep your function pure as much as possible. Next, you can also consider splitting your code base into smaller chunks and load them on demand when user needs it. Fortunately, modern frameworks allow you to do it without any problems. And just revisit your application and analyze. Maybe some features are less used and might be excluded from the main bundle and loaded later on when the user decides to navigate to some specific page, for instance. And the same can be applicable for your styles. You can load them on demand as well. For instance, you might have some dark theme and light theme, but because only one theme can be activated at the same time, yeah, there is no need to load all of them. Yeah, do it later when the user really needs that, when he like ticks the checkbox like dark theme, and only then load the CSS that are responsible for this theme. So chunking might be a very useful technique that can drastically increase the initial page loading performance. The next trick you can consider is using async and defer attributes. So how it works, when the browser loads HTML and comes across a script tag, it cannot continue building the DOM. It must execute the script right now, and that's why the rendering is being blocked. Yeah, and when browser and enters the third-party script, like you can see right now, like application.js file, browser must wait for the script to download and then execute the downloaded script, and only then the process of building DOM can be proceeded. It leads to the two important issues, like script cannot see DOM elements below them. So if you have JavaScript code that needs to add some on-click handler for the click event, you cannot do that because the DOM element below the script doesn't exist at this point of time, probably. So this is the one problem. And if the second problem, yeah, as I said, it's blocking the rendering. So if you have some heavy script or a lot of scripts at the top of the page in the head section or in the head tag, for instance, users cannot see the page. It sees the blank page until all those scripts are being downloaded. There are some workarounds for that. For instance, we can put script at the bottom of the page, then like it can see elements above, and user will see some HTML immediately. But this solution also far from perfect, because then browser will start loading the script only when it reaches this bottom of the HTML document. So it might take some time if the page is really big. I mean, not too much time, like few seconds or something like that. It's about milliseconds, but you know, milliseconds there, milliseconds here, and then you have the delay of 1 second or something. But these async and defer attributes, they help you to avoid this blocking issue. The defer attribute tells the browser that when you reach the script, do not wait for loading the script. Instead, browser continues to process the HTML and build DOM, but the script loads in the background, and then it will be run when the DOM is fully built. There will be dedicated JavaScript event fired, and then scripts will be executed. Regarding async attribute, well, async attributes, it is very similar to what defer does, with the only one difference is that async doesn't care about the first the order which scripts are defined. The async script will be executed immediately when it is loaded, so it can be executed even before the DOM build, and it can be executed later. So like as soon as it is loaded, it is being executed. It doesn't wait until page or anything else. Yeah. So this is for it could be a good option for completely independent scripts, like some maybe analytics, Google Analytics stuff or whatever. It can be used, can be loaded using async attribute. Also, you can improve assets loading using preloading at prefetching strategies. Such a way you can preload and prefetch, I know, fonts, some CSS, and the difference between I mean, what is important here to mention is that preload tells browser that start loading this asset like immediately. Don't go like don't load me when you just during the parsing, but immediately when just page is requested, it will start to preload assets. And what is also important, they are not being activated. They're being loaded and they wait until they will be activated. So activation should happen like on your own. And preload and prefetch, the difference is that prefetch has lower priority. Like prefetch could be used when, like preload is useful when you need it immediately, and prefetch might be useful when you need some style or font, maybe for the next page or something like that. So if it's something that needs to be used later, then you can use prefetch. Yeah, JavaScript runtime. There are also a couple of tricks how you could improve that. You can use web workers if you need to do some heavy computation that might block the main thread. You can use web workers to do this computation there. So such a way you can move some expensive task, and your UI will be always responsive. You can use service worker for perform caching or perform some other stuff related to the networking. This is the service worker. This is the thing that sits between network and the browser, and and you can manipulate with the network, do offline experience. So if you build a progressive web app, this is kind of essential thing. You can use also memorization techniques using different libraries for that, like Lodash memoirs and some other libraries. This library can help you. The idea behind the memorization is that when some function gets the same arguments, it will not be re-executed. Rather, the result will be already reused. It will be called once, and then this result is saved in the memory. And then when you call the same function with the same argument, it will say like, why should I re-execute it one more time? I will return immediately the appropriate value. So yeah, this is memorization, and avoid memory leaks in your JavaScript. Memory leaks can decrease the user experience, and when user use quite a long time your web application, memory leak can be caused of problems. And bad user experience. Then you can use intersection observer API. This is a cool feature. Actually, it allows you to track when some target elements enter the viewport. Yeah, so when it enters the viewport, the observer you can react on it, and then you can play, for instance, the video. Yeah, if you don't want to play it immediately, you can start to play video on demand, or you can load images such a way, or you can load some script such a way using lazy loading. Yeah, something like that. And yeah, let's quickly have a look at the tools that help you measure performance. I don't use any special tools or something. I use Google Chrome DevTools, and there is a tab Lighthouse, a very useful one. I would say this is the good entry point for where you can start analyzing the performance of your application. It gives you some feedback and set of hints what can be improved and how it can be improved. It gives you links to different documentations where you can find answers to your questions, how to improve this or that parameter. So this is a very good entry point when you start analyzing the performance of your application. If you need to analyze the runtime performance of JavaScript, there is a tab Performance. There you can record, do the recording. So you start recording, then you interact with your UI, then you stop recording, and it gives you some visualize what happened during this process, which scripts were called, and so on and so forth. And such a way you can discover some bottlenecks and figure out what is wrong with your runtime performance. And of course, like network tab could be also useful, but I would not recommend you to start immediately from this network tab. Start with the Lighthouse tab. Network tab can help you later on. Like there you can discover maybe you have some duplicating requests, or you can analyze separately each single request to see how much time it takes to load, and things like that. Pretty sure you all know this tab. And how to find time for all those optimizations. Yeah, we are usually busy developers, but sometimes we should not reinvent the wheel, and to increase the team performance, we could use already ready solutions. For instance, if your application needs some file uploading feature and the processing of these files and do many other things, maybe it's like you can do it from scratch, but you can use already dedicated services for that, like Filestack for file uploading, or if you would need, for instance, some rich text editor, you could use editors like Prala that can help you to spin up the rich text editor just in less than 1 hour. And can you imagine how much time would it take to implement from scratch? I don't know, months to quite a lot of time. So imagine what you can do with your performance if you dedicate this 1 month only to the performance. So this is something we should always think about. And this is pretty much it. Thank you for your attention. I hope it was interesting, and then our dear sponsors right here, and we have 5 minutes of QA session. So if you have any questions, I will try to answer it if I know the answer.
Thanks, Dimitrio. One question is, where usually do the performance bottlenecks appear in web applications?
Oh, that can be everywhere, but usually it's as I said, it's graphics. Yeah, and if we're talking about runtime, JavaScript, it's manipulation with the DOM. This is one of the most expensive operations when you add some HTML, remove some HTML from your page using JavaScript. So that's why modern frameworks like React, Angular, they try to differently solve this issue. So how to touch the HTML to manipulate it as less as possible. So that's why React has virtual DOM, to solve this problem. Angular has its own approaches like incremental DOM. So yeah, I would say those are one of the most bottlenecks, but of course it can happen everywhere. Yeah, this is performance. It's quite an unpredictable thing. You always have to test and measure, and then fix.
Yeah, and another question is, why are CommonJS imports tree shakeable?
Tree shakeable, they are, I think it's a mistake. They are not tree shakeable. They are, as I said, they're not completely, how to say it? they are 3 giga, but it's very hard for Webpack to detect that because they are dynamic and they can be used. For instance, CommonJS, or when you import some model using require, you can do that in some if-else conditions. And if like it might happen at the runtime, and bundler cannot know what will happen at the runtime, and because of that, CommonJS might be can be a problem. Unlike ECMAScript imports, they are static. You cannot use them in runtime somewhere. Like in runtime, you cannot use them in, I don't know, in if-else statements or something like that. And that's why they are, for Webpack point of view, they are reliable. Yeah. So if it is easier to detect for Webpack what is used, what is unused in this case. So that's why CommonJS is like not a good option. It was initially developed for the Node.js, CommonJS, where there's no problem, such a problem as a bundle size or like something like that. So they didn't, when the CommonJS was developed, it was not like focusing on this thing.
Thank you. And I think the final one is it possible to define thresholds for loading lazy attribute in images? For instance, image needs to be loaded when the user scrolls 500 to 600 pixels near them.
As far as I know, you cannot do that. Maybe in the future we will get such a cool option, but as far as I know, you cannot do that. The browser decides on its own when the image will be loaded. Yeah, but you cannot tell exactly. You can use where I had you can use this feature, intersection observer API, to detect that, because there you can define the thresholds, as far as I know. So yeah, you can define that, load the image when it is 300, or how it was the question, 300 pixels before the like entering the viewport. So yeah.
Okay, thank you.
Then yeah, if it's the last question, then again, I will go to the very last slide. And
all right.
Thank you very much. Thank you all.
Thanks, Dimitro. And thanks everybody for watching our webinar. Our recorded version will also be available shortly on our social media channels. If you want to read more interesting content and try out our products for free, just visit our sites, filestack.com and forwala.com. Thank you again, and we hope to see you in the next webinar. Bye-bye.
Bye-bye.